pulling your hair out about trying to figure out whether or not molecules are polar or non-polar. I'm about to show you a very visual way to be able to figure it out. When you have a polar covalent bond, one side of the bond is more negatively charged, the other side of the bond is more positively charged. And this is because the difference in electronegativity of both of the elements. I'm going to assume you know what that means, otherwise go and search it up. This can be visually represented like this. So they'll use an arrow, also known as a vector, where this little bit here represents the positive side of that bond, and it points towards the end that's more negative. So you can see here, nitrogen and oxygen, it's pointing from nitrogen to oxygen, which means that oxygen will be more negative than the nitrogen side, right? Because there's a difference in electronegativity between the two atoms. What you'll notice here is the size or the magnitude of those arrows also make a difference. So the bigger the size, the bigger the difference. So the difference between N and O is this size. The difference between C and O, you can see that the arrow, the magnitude of the arrow is bigger because the electronegativity difference is bigger. And also same thing with H and O bonds. So this is really useful because it helps us try to figure out whether a whole molecule is polar or not. So we've got carbon tetrachloride, which means you've got the carbon there, 4 bonds, each of them to a chlorine atom. These carbon to chlorine bonds is a polar bond. So you can see here, represented by here. So it's pointing towards the chlorine every single time to the same magnitude. Now, because that's the case, all of the vectors cancel each other out, which means in total, even though you've got polar covalent bonds in this molecule, the whole molecule isn't polar. Let's look at another molecule with, again, 1 carbon attached to 4 atoms. The arrow is pointing from the hydrogen to carbon, which means carbon is slightly more electronegative, but it's not so much to enough to be polar, right? So we wouldn't really consider this as a polar covalent bond. But you also look at this, look at the carbon to chlorine bond. You know that this is a polar covalent bond going from the partially positive end here of carbon to the partially negative end here of chlorine. And you can see even the magnitude of that vector is overall greater. So looking at this molecule overall, there's an overall charge difference where it's more positive on this side and it's more negative on this side of the molecule. As a result, the whole molecule itself is polar.